In Section 4 of Unit 6, our solving of linear equations takes another step, a very important step. In the remaining lessons of this unit, we will use algebraic techniques, algebra, in order to solve our equations. These techniques will be used throughout the remainder of your math career for all types of equations. The remaining videos in this unit have been organized into different types or formats of linear equations. In video 1 of lesson 1, our linear equations will take the form of x plus a equals b, where a and b are integers. Just to recap, what does it mean to solve an equation? Well, that's finding the specific value or values for the variable that make the equation true. And in grade 7, how many solutions will our equations have? Only one. We have already examined how to solve linear equations through systematic trial, inspection, and then through our modeling processes of balanced scales and algebra tiles. And now, algebraically. We still isolate the variable to determine its value. In other words, get the variable by itself. 1x, 1f, 1m. You get the idea. And one final point here before we get started. Addition and subtraction are opposite or inverse operations. Similarly, multiplication and division are opposite or inverse operations. You will see how this becomes important as we proceed. First, we examine linear equations of the form x plus a equals b, where a and b are integers. And you should now be familiar with the set of integers. Solve for x. X plus 5 equals 7. And for this first example, even with doing it algebraically, I want us to just revisit our algebra tiles. So if we were to represent this equation, x plus 5 equals 7, this would be our variable tile, our 1x, our 5-unit tiles, and on the right-hand side, our 7-unit tiles. So left-hand side, right-hand side, left-hand side, right-hand side. If doing this using algebra tiles, your first step, we would take away this representation for positive 5 or plus 5. And whatever we do to one side, we have to do to the other. Algebraically, I just transfer what we did into symbols. So x plus 5 is what we had. What did we do? We took away 5 positive unit tiles. And whatever I do to one side, I have to do to the other. So if I subtract 5 on the left, I have to subtract 5 on the right. The idea of the inverse or opposite operations to point this out. So to get rid of a plus 5, I have to do the opposite, subtract 5. That's my first step. And we know that plus 5 subtract 5, positive 5 subtract 5, they just cancel out. That just gives us 0. If I remove these 5-unit tiles, there are no unit tiles left, just left with an x. And on the right-hand side, I'm left with 2 unit tiles, and of course 7 subtract 5 is 2. And we have solved it algebraically. X equals 2. We will verify our solutions here as well. X plus 5, and I put in my circle as I've been doing all along. In place of the x, we just found x to be 2. So 2 plus 5, does it equal 7? 2 plus 5 is 7. 7 equals 7. We're good. Let's try a few more examples. Solve for n, and our equation is n subtract 3 equals 18. Our task here, we got to get this n, this variable, by itself. When I look at what's associated with it on the left-hand side, we have a subtract 3. If we think about that idea of inverse or opposite operations, what's the opposite of subtracting 3? Well, that would be adding 3. In subtract 3, I add 3 on the left-hand side. But if I add 3 on the left-hand side, I must add 3 on the right-hand side. Whatever I do to one side, I do to the other. And subtract 3 plus 3. So this subtract 3 plus 3, that cancels out. That just gives us 0. So we're just left with what we want, which is our variable n, 1n. And if I add 18 and 3, that gives me 21. N equals 21. As we proceed through these examples, we will be including this particular step. But I do want to point out, as you gain more experience solving equations, you may start taking a few shortcuts, we'll call them. So if this is the original equation again, n subtract 3 equals 18, you may just do this, plus 3, plus 3. So you're still showing what it is you're doing to both sides. You're just not writing out a complete step. And then you would jump right to n equals 21. That's okay. But for now, as I said, we are going to be including this middle step right here. And as before, we're going to verify. N subtract 3, circle 18. We found n to be 21. I replace n with 21. 21 subtract 3, 18. And 18 equals 18. Our solution must be correct. Solve for p. P subtract 7 equals -9. My variable that I want to get by itself, right there, 1p. What's associated with it on the left-hand side? I got a -7. To get rid of subtract 7, the opposite to that is add 7. And whatever I do to the left-hand side, I have to do to the right-hand side. I added 7 on the left, I must add 7 on the right. What happens here now? Subtract 7 plus 7, 0. Left with p, 1p. -9 plus 7, if you think back to your work on integers, that will equal -2. P equals -2. Let's do a check. P subtract 7, -9. In place of the p, we put our -2. -2 subtract 7, and -2 subtract 7 is indeed -9. P equals -2 must be correct. And right now, I'd like you to take a little break, take a few minutes to let those examples sink in, and then proceed to the next video in this lesson that will further examine examples of this form.